Okay, ladies and gentlemen, I've got my new microphone I am testing out here, and I hope that helps out a little bit with the quality of the sound. I've also got my red shirt matching my red background. I hope you guys are ready to learn tonight. So the first thing I want you to do is pause my recording and go ahead and copy everything you see on the screen. It might look like gibberish to you, but my job is to try to make it simple for you and explain it. Okay, I'm going to trust that you have taken the time to copy everything that's on my screen here. Today's concept, we want to talk about this thing called similar triangles, okay? And similar means that they have the same shape, okay? They have the same shape, but they're different size, okay? So, for instance, if you look over here to the right here, I've got a couple of triangles. You'll notice that they basically have the same shape. And yeah, they're just different sized. Okay. And so they're similar because here's a couple of things that correspond. We're going to use this word corresponding here, which means they have the same angles. So, for instance, if you look over here at the first triangle on the left, angle A, okay, is 35 degrees. Look all the way to the next triangle to the right, and angle D is also 35 degrees. So those two angles are what's called corresponding angles. Okay. They match each other. Likewise, angle B is 91 degrees. Angle E is 91, and angles C and F are also corresponding angles. Okay. All right. So not only are there corresponding sides that we can look at that are the same, but they're also corresponding, I'm sorry, angles. There's sides as well. So if you look at side AB here, which is up at the top here, okay, running this way, okay, that side corresponds with side DE, okay. They correspond with each other. Now, I want you to notice something here. They're not the same size, but they correspond with each other, which means they're kind of the matching side. Okay. So side BC, which is this one that runs this way, okay, on the first bigger, larger triangle, corresponds with side EF. Okay. And that's what my directions I've got here at the bottom of the screen. So they're all kind of corresponding. They're what kind of match with each other, pair up with each other. Okay. Um, and so you could think of them as like a child that looks just like the parent, but it's a lot smaller. Okay, same eyes, same features, but they're just different sizes. All right. So that's this thing called a similar triangle. Now, at the upper right-hand corner here, I'm going to circle something I want you guys to see. This little symbol here, I'll try to make a better one here. It looks kind of like this. It means similar, means that the two shapes are similar to each other. Okay, so that's a little bit of the language. Moving on to the next slide, we now have an example problem. Okay, so I'm going to have you take a minute, pause the recording, copy this down, and then we will continue. Okay. Example problem. So in triangle XYZ, okay, this is XYZ, the first one here on the left. Angle X is 19 degrees and angle Y is 76 degrees. Okay. In triangle GHI, that's the second one to the right here, GHI, angle G is 85 degrees and angle H is 19 degrees. Is triangle XYZ similar to GHI? Okay, that sounds like a lot of math, but basically all we're asking here is, do these two have the same angles? Okay. And so that's an example of problem that you're going to run into on your test at the end of this unit and also in your homework. I'm going to break it into steps, how you could solve this problem. Okay. Step one here. Angle X plus angle Y is 19 plus 76, which equals 95. Okay. So I'm looking at here, this first larger triangle. If I add those two angles together, okay, that comes to 95 degrees. Okay. We know that all three of those angles from last session add up to 180. Okay. So if I take if I add the two angles I'm given, add them together and subtract that from 180, that gives me 85 degrees. Okay. Which tells me that this one here, okay, this angle here, Z here, is 85 degrees. All right. Now, again, we would know they're similar if they have all three of the same angles, right? All right. But so now we're going to step two here. We're going to go to step two. Angle G plus angle H is 85 degrees. So what we're looking at is this top triangle here. Okay, I'm going to add those two triangles, those two angles together, and I'm going to get 85 degrees. Okay. Um, let's see. So angle G plus angle H is 85. I'm sorry, 85 plus 19 is 104 degrees. Okay. So I added the 85 plus the 19, and I got 104. Probably guessing what to do next. I'm going to take 180 degrees, subtract 104 from it, and that gives me what's left, which is 76 degrees. Okay. So this one up here would be 76 degrees, this angle here. All right. Step three is to compare the two triangles. The answer is yes, triangle XYZ is similar to triangle GHI. Let's take a look at Y. Okay. XYZ here at the top has a 19, a 76, and an 85. GHI has a 19, a 76, and an 85. Bingo. That proves that these two are similar. Now, if you ran into the situation where, say, it was 60 degrees here, this angle I was 60, but it's 85 on Z and stuff, and there's no 60 in the other one, you would answer, no, they are not similar. They do not have all three angles the same. Okay. All right. So what I want you to do is I want you at the end of this slide, I want you to stop this recording. I want you to do questions 1 through 6 on page 53, just to really familiarize yourself with this concept. And I'll come back here in a moment with the next slide. Okay, I hope you're ready to roll here. So go ahead, if you haven't done so already, copy down, pause this video, copy down everything you see on the screen. And I know it seems like a lot, but we will go through it all and try to explain it, make it as simple as possible. All right, equivalent fractions review. Okay, I'm going to start off with a little review concept here. Okay, you might remember way back when you were learning fractions that there are fractions that are called equivalent with each other, which means they're really the same fraction. Okay, and so like I used to teach a fractions class for the college, and you see if I divide this thing in half here and I fill in this, okay, that's half of my pizza or whatever it is. Likewise, if I cut it the same pie, the same pizza into 4 pieces, okay. So the first one is as a fraction is 1/2, okay. But you see that's half of the whole thing. If I cut it into 4 pieces, okay, but I still shade in the thing, you can kind of look and see that, oh, it's actually the same. Visually, you can see that it's the same as the 1/2, even though this is 2 out of 4 pieces over here. It's the same fraction. Okay. And so that's what we mean when we're talking about equivalent fractions. So for instance, 1/2 is the same or equal to 2/4. Okay. And by the way, if you ever wanted to prove you weren't sure that two fractions were equivalent to each other, cross multiply them. So if I cross multiply 2 and 2, I get 4. And if I cross multiply 4 times 1, I'm going to also get 4. Yes, that proves they are equivalent. Okay. Likewise, the fraction here, 3/5 and 6/10, okay, that's an equivalent fraction, but let's prove it. 5 times 6 is 30, and 3 times 10 is 30. So, yep, these two fractions are equivalent. All right. Okay, let's take a look at an example situation here. Because triangle ABC and triangle CDD have a corresponding angles, they are similar triangles. Okay, so we've got these two triangles here. And the first one on the left has a 35, a 91, and a 54-degree angle. 35, 91, 54, they're both equivalent. Okay. Now, again, I want you to notice they're different size because side BC here on the first triangle is 21 inches and EF is 30 inches. Okay. So we can create equivalent fractions. Okay. So step one here, I'm at the bottom here. Side AC and DE are corresponding sides. Okay. So what I want you to look at here is this is side AC here. It runs from A all the way to C here. Okay. That side corresponds with and this other side down here, DF, they correspond with each other. They're kind of they pair together. Okay. Likewise, side EF, let's see, where am I at? DF and AC. Okay, I've got it upside down, but it's DF and AC. Likewise, EF, which is this one over here, would correspond with BC. Okay. And so that's what I've got written over here at the bottom of the screen on the left here is that those sides correspond with each other. And if I take my lengths, in inches, 50, which is side DF, where's DF? It's down here. It's 50 inches on the far right at the bottom. Okay. This one right here. That's 50 inch. That corresponds with 35 in the other one. So it's 50 over 35 here on the far left. That's a fraction. They correspond. And then I've got 30, which is this one EF, corresponds with 21, which is BC. Okay. And if I did the math again to see if they correspond, I could cross multiply like 50 times 21, and I would get 1050. And if I cross multiply 35 times 30, I'm going to get the same number. Okay. So we're just looking at similar triangles. These two triangles to each other are similar to each other. Okay. And we can create these fractions, which is going to become important in a moment. If you're wondering, teacher, why are we doing this? Well, I'm about to show you why that becomes really important because we're going to have to solve a mystery. Okay. All right. Now, I want you to pause the recording. I want you to copy what's on the screen, do your best to draw it out, and then turn it back on again. Okay, I've got some keys to writing a correct proportions. Okay, and we want to write correct proportions. So these are some keys to doing this. Okay, number one, find the corresponding sides. Okay, all right. Number two, the denominator, the numerator, that's the number on the top of a fraction of each fraction is from the same triangle. And then number three, the denominator from each fraction is from the other triangle. All right, you're probably thinking, teacher, that just went right by my head. I'm kind of confused. I'm about to try to make that simpler, okay? I'm going to choose a nice blue color here to put on the screen. So let's look at these two triangles at the top right here, okay? Let's look at these two triangles here, okay? All right, so can you figure out which sides are kind of corresponding with each other, okay? I'm going to tell you a little secret. It's actually kind of a two-way secret here. Look at the first triangle on the left. You see the angle, this angle here, it's got angle 47, and then it's got an angle 73 here. There's 73 degrees, okay? To find the corresponding, let's just number this one 1. We'll just put a 1, a nice blue 1 here. And I would highly recommend you do the same thing. That side we're going to call side 1. Okay, so we've got a 47 and a 73. Let's go over to the other one. And do you see that we've got a 47 here and a 73? That's the match, those two numbers, that's our matching side 1. Okay, and so you put a 1 right there. Okay. Likewise, if you look at, look at the other, let's see here, how would I recommend here? Let's take, let's look at the 42, okay, that's at the top here. I'm going to draw my arrow pointing towards it, okay. Let's call this side 2, okay. Then what's the corresponding one? So that is between, look at the numbers now, 60 degrees and a 47 degrees. Well, you can see the 60, 47 is right here. So at the top of the other one, so that's a 2. So those sides correspond with each other, okay? And then likewise, I'm back on the larger triangle on the right. I've got a 60 and a 73. Find my 60 and 73 over there. I'm going to put a 3 there, and I'm going to put a 3 here, okay? Those are now all the corresponding sides. Now, for these two triangles, it's somewhat easy to figure out because they're really similar in shape and they're all pointing the same direction. But that won't always be the case. Sometimes they're going to be pointed totally different directions. And so That's where my little blue numbering system, highly recommend it. So you get the right corresponding sides. Okay. So what we've got here is that really helps us to match up things and make the right fractions here. I'm going to go back up to the very top of the page where it says problem, okay? And I've got 12 over 36 equals something over 27. All right, what's side 12 here? Look at this. Side 12 is this one I'm circling right here. Okay, that's that side one. And sure enough, it matches, goes over 36. It corresponds with this side one over here. So that's how I got 12 over 36 here. Okay. And then it says, so I'm going to go back to the numerator. Okay. You see how it said the numerator is of each fraction is from the same triangle. Okay. So my numerator has to come from this first triangle here. Okay. So it's something x over 27. Okay. Well, look at 27. 27 over here on the right is from the second triangle. It's from side three. So all I've got to do here, to see I'm circling it here, 27 on the right is from side three. That's where that 27 came from. I'm going to draw an arrow here. Okay. So I need to match it with side three and the other one. And here it is here. I'm drawing it, kind of filling in that three. It's a 9. Okay. I'm going to put this 9 here. That is my fraction. And I can multiply those crossways and it should come out to the same answer. Okay. Let's take a look at the second example, problem number 2 here. All right. The second example. All right. It says 7 over 35 equals what over 20? Okay. So 7, first of all, let's call 7 here. Let's number this our number 1. And it goes over 35. So we're going to call this our number 1. And again, I highly recommend you take your bright colored pencil and do the same thing I'm doing. So it makes it easier. And so you don't get them confused. Okay. Equals something over 20. Well, 20 is, we'll call this 2. And so this one here is going to be our, see how it's between 74 and 55? Okay, 74 and 55. Going to call this 2. That means this has to be 3. Okay. So 7 over 35 equals something, okay, something over 20. Look at the number here. It's going to be a 4 here, okay? This corresponds with this one here. These two correspond, 4. And then I could cross multiply and should get the same answer. Okay. Now you're probably thinking, hey, teacher, it's right there on the screen. So what's the mystery? Well, let's take a look here. We're getting there very quickly. All right. So you're going to run into some problems. Don't be fooled because the triangles are turned in a different direction. Okay. Try the number in each side. That's what I've already mentioned on the other example. So like, for instance, look at these two triangles here on the left here. Okay. They are definitely turned different directions. And so I picked, and here's what I always do, and this probably is a great idea. I pick the smallest triangle and I pick the smallest dimension here. And so it's this 15. See how it's 15 feet? You got a 15, 18, and a 21. So I made my smallest number my number 1. Okay. All right. That's between 97 and 46. Do you see that? The angles, 97 and 46. I'm going to come over to the other triangle, which is turned totally differently. Here's my 97 and my 46 here. Okay. So that's my number 1. Okay. There it is right there. All right. My number 2 is for the 18-foot one. Okay. Coming back to the left triangle. It's between 97 and 37. I'm going to go back to my other triangle, 97, 37, named it 2 right here. Okay. And then by default, the other one's 3. All right. Now I've got this little fraction over here on the side, 18. Okay. 18 is side 2 over, see this 18 right here. Okay. Over what? Okay. Well, it's side 2. It needs to go over side 2. Look, what's the number for side 2 on the right? I'm going to circle it. This is side 2. So it's got to be 24. And this little method will help things be real clear for you. Equals 15. And what was 15? That's side 1 over, it had to be side 1, 20. Yeah, sure enough, they match. And then you would cross multiply to verify that you get the same answer. Okay. All right, we're kind of slowly leading you, but this is really important this because this is a place where some students start getting a little bit confused when you start seeing triangles that are they're totally different. They're different, they're like turned different from each other. Okay. All right. So here comes the mystery thing. Example problem. All right. First thing I want you to do is pause the video, then turn it on when you're ready with all of this stuff copied down. Example problem. What is the length of M? Okay. So I'm going to pause here, make sure you're really clear. They're asking for this length right here. Okay. And so that's at the bottom of the screen here on the right where my blue arrow is going. That's M. They're asking for. Now it's a mystery. They haven't given it to you. What is the length of M of of side LN? And sure enough, that's side LN there at the bottom from L angle L to N in the triangle LMN to the right. Okay. So what we're going to do is we're going to write a proportion using corresponding sides. Okay. So solve by cross multiplying. All right. So what we're going to do is we don't know. We're going to create a proportion. Okay. So look at over here at this top triangle here. You see how side one is 12 feet? Okay. So that's where I'm going to put, I'm circling down the bottom here. I'm going to put 12 over 9. So that's 12. Yep, that matches up. This one matches up with this one. The ones match together equals, okay. And then I'm going to go back to 8 here. That's the 8, which I'm going to put right here, okay, right there, okay. Over, and we're trying to solve for M. Okay, 8 is side 2, so M is side 2. They have to match. So that's where we get this proportion that's gone here. 12 over 9 equals 8 over M. All right. Some of you right now are thinking, wait a minute, we're talking about letters here. How am I going to do that? If I remember that was like algebra. Okay. Well, I'm gonna slow down for a few minutes here and kind of show you a little bit of basic algebra. And that's all we have to know is just a little bit of basic algebra. Written, if we cross multiply here, 12 over 9 equals 8 over m. If we cross multiply, 12 times m is going to give me 12m here. Okay. And we're going to write equals, and then we cross multiply 9 and 8, we get 72. Okay. So 12m equals 72. All right. Now, what I illustrated for you way back, if you remember some of your algebra, you're trying to get the letter on one side of the equation all by itself. Okay, so we want that m all by itself. So we got to get rid of any numbers that are next to it. Okay, well, if I have 12m, I'm multiplying, aren't they? 12 next to something means 12 times m. Okay, the way to get rid of it is to do the opposite operation in mathematics. What is the opposite of multiplying 12 times m? It's to divide something into it. Okay. And so if I divide the side on the left by 12, which is what I've written here at the bottom here, okay, I have to do the exact same thing, whatever operation I do to one side. You might remember you have to do the same thing to the other side. So I'm going to put 12 over m, or 12m over 12 equals 72 over 12. Okay. Now, if you forget what to do next, these two 12s are going to cancel each other out. Okay, they become like 1m, which is just the same as just m. Okay, so now I have m, and don't worry, I'm going to show you some more examples on the next slide. Equals, well, how many times does 12 go into 72? It goes into it 6 times. Okay, so what we just did is we solved a mystery here. This m is what this mystery length is here. And that was what I told you was coming is we can now find out if the two triangles are similar, but we're missing one of the lengths, we can create a proportion of two fractions and then solve for x or m or whatever you want to call it. Okay. And then I want to remind you before I go to the next slide, my little green reminder here is that it really helps to number the sides so you can remember which ones go together. Okay. All right. Moving on to the last slide for this session here. And that is some basic algebra review. Okay. We're just going to go through some of these just to review. So, if I created two proportions and maybe this 8 over 16, that was side 1 over side 1, and this was side 3 over side 3, okay? 12 over D. They're both sides 3, okay, of the true triangles, okay? So we're going to create it's a very basic algebra problem. We're going to cross multiply here, and we're going to get 8D equals, okay? And if you take your calculator, which I'm going to do right now, turn it on first, is on, come on, clear. 16 times 12. And that would give you 192. Okay. So I've got 192 here. All right. Now, do you remember how to solve it and get D by itself? Distance D, okay? You're gonna, because 8D means 8 times D, opposite operation of that is division, okay? If I divide by 8, those two 8s are going to cancel out and they're just going to create 1D or just D, okay? Whatever I did on that side, I have to do on this side, okay? So 192 divided by 8 should give me 24, okay? So D equals 24. Let's do it again, okay? Let's look at the next problem to the right, number 2 here. I've got 50 over x equals 40 over 48. Okay, let's cross multiply. 40 times x is 40x equals, what is 50 times 48? 50 times 48 equals 2400. Okay. That's a nice looking 2 there, isn't it? Okay. 2400. All right. How are we going to get x by itself? It's 40 times x, that's times. So the opposite operation of times is to divide by 40. And whatever you do to one side, you're going to do the same to the other side. Okay. So, oops, I wrote 44 here, didn't I? Okay, that's a 40. Now, again, these two 40s now cancel each other out because 5 divided by 5 is 1, right? 4 divided by 4 is 1. 40 divided by 40 is 1. So I'm left with x equals 2400 divided by 40, which gives me 60. Okay. All right, 60. So I've just solved for x. Okay. Let's do it a couple times more. Okay. Look, if I create the proportion of 12 over 20, remember that might be side 1 corresponding with side 1 of the other triangle. And let's say this is side 2 over side 2. Okay. And remember, these two things at the top will be from the same triangle. And these two denominators will be also from the same triangle, side 2 or side 1 maybe, and side 2 of both. Okay. All right. And again, so 20x, that's going to give me 20x equals 1, 2 times 15 equals 180. I think you guys know what to do by now. Next, okay. I got to get rid of that 20 to get x all by itself. So I'm going to divide both sides by 20. And I'm going to get x equals 180 divided by 20, 9. Okay. And there's my answer. All right. I think I've done enough of these to give you the idea of what you're going to be doing. Now, if you're stressed right now thinking, teacher, are we going to have to do a whole bunch of algebra? The answer is no, just a little bit of algebra here to solve for x, solving when you have similar triangles for that missing side. Okay. All right. So a quick reminder again, use my numbering system, my blue numbering sign for side 1, 2, 3, and 4. That'll help a lot. Also, at the end of this video, complete all the problems on pages 56 through 61 in your textbook. And I'll just give you the heads up. There's going to be a whole bunch of story type problems. Use my advice and draw the pictures. And I want to show you one example, though, of something that you're going to see just real quick. I'm going to draw this triangle here on the screen here because you're going to run into this, okay? You're going to have something like this, okay? And it's going to ask you, this might be called A, B, C. Oops, that's a terrible B and a C here. And this might be D, and this might be E here. Okay. So technically, if you look at it, if you look at the big triangle that's on there, we've got a triangle that's ADE, and we've got a triangle that's ABC. Okay. And so just know that if you run into that in the story problems, you're going to look at the dimensions from here. That would, let's call this our one from A to B. That'd be our side one, say. Okay. Well, the side one for the big triangle is from A all the way to D. Okay, it's the same side as the small triangle. Look at BC here. We'll call that side two. What's side two in the other triangle, other the big triangle? I'm just looking at the small one here. Okay, BC. That's BC. What's the corresponding side? It's this one here. This would be side two. And then if this is side three here from A to C, then what is side three for the other triangle? All the way from A to E would be side three. Okay, that'll help you out a lot. Good luck. Be sure and send me an email if you have any questions, and keep up the great work in my class. Thanks for coming.